Okay, so we are going to start our unit today on inferences and conclusions from data, and this first topic focuses on normal distribution curves. So everyone open up your new packet, and you see there's a series of images on pages 1 through 5. What I'd like you to do is to please pause the video and sort the images. Create some sets. Consider what their distributions look like, if the images are symmetrical, how spread out they are, their mean, do they have one peak, are they uniform, and title your groups. Okay. All right. So now I'd like you to take a look at this graph. This graph shows the heights of a random sample of 100 men ages 20 to 29, and we have their graph. What do we notice about the results? Hopefully one of the things you notice is that the graph is symmetrical and it has its peak, its mode, in the center. What would this data look like? Well, if we were to graph these, the heights of 100 NBA basketball players with the same age would probably look a little different. Maybe we would expect the NBA players to be a lot higher and more uniform, not so spread out. Maybe we would expect their boxes to look more like this, like they all would kind of all are the same height. They're a lot taller. You know, this is just an example. We would expect them to be a little more uniform, perhaps, and significantly taller. The point is that each of these histograms, well, this one maybe not, I have to alter a little bit. There we go. Represents a normal distribution, and that is going to be the focus of this first topic. Okay, so car prices are another example of a normal curve. And what I'd like you to do is go back to pages 1 through 5 and identify which distributions are perhaps normal distributions. Pause the video if you need more time. Okay, hopefully you said images 3, 5, 6, 8, and 10 all represent normal distributions. Okay, so which of these scenarios could be modeled by a normal distribution? We have 40 passenger cars in the U.S. are randomly selected for their fuel consumption and measured. 16 wolf dens in Yellowstone National Park are randomly selected, and the number of pups born in each litter were measured. 28 apple trees in an orchard were randomly selected, and the total weight of the apples from each tree were measured. And 50 neighborhoods in Denver, Colorado are randomly selected, and the crime rate is measured. If you guessed scenarios 2 and 3, you were correct. Okay, so everyone flip to page 7. Here we've got a frequency distribution. And over here, we've got a distribution curve. Right. Then we have a third image, and this shows both a frequency distribution and a distribution curve laid over top of that particular frequency distribution. So what do you think the difference is between a frequency distribution of a histogram and the distribution curve? The distribution curve simply smooths out the bumps in the frequency distribution. Right. So over the next few pages, I'm going to present you with 2 graphs at a time. One of them will be a normal distribution curve, and one of them will not be a normal distribution curve. What I'd like you to do is pause the video and take about 5 to 10 minutes examining the graph pairs on pages 8 through 11, and make a note about what the differences are between each group. Okay, pause the video if you haven't given yourself enough time, because we're going to start to go over them. All right. Nope, that was on our page. All right, so number 2, we've got the first 2. This is a normal distribution curve. This is not a normal distribution curve. And I notice the one that is not normal has more, it's more spread out on the left. Perhaps these are outliers, perhaps they're not, but there's definitely more spread over here on the left. So I say that the left histogram is symmetric, but the right histogram, this red one, is skewed to the left because the left is where it is more spread out. Now for number 3, I have the opposite situation. This is a normal distribution curve, and this is not a normal distribution curve. And I see on this curve it is more spread out on the right side. This is more spread out. And as a result of being more spread out on the right side, this one is skewed to the right. Now I also notice, if you look really carefully, it's hard to see on the screen, but this red line has the mode, this blue line is the median, and the black triangle is the mean. Whereas on my normal distribution curve, the mean, median, and mode are all exactly the same point. But the one that is spread out on the right has pulled the mean and the median further to the right. For number 4, I've got this nice bell curve, and then I have heights of students. This is similar to number 2. It's more spread out on the left, so we say it is skewed left. Now, number 5, the one that is normal, I see it's 1 standard deviation up and down from the mean. I have points of inflection, meaning I flip from concave up to concave down to concave up. This one, I see I've got a mode here. I've got another like kind of hump. It's not a mode, but it's definitely a point of interest because all of a sudden the data comes up there. So I can say that the second graph is bimodal. It almost has 2 peaks. So graph number 6, it's got 3 peaks. I don't know what else to say about that. Okay, so now we've got some box and whisker plots in addition to our histograms. So that's a fun time. I notice the box and whisker plot is symmetrical, but the one that is skewed to the right, the box and whisker plot, is spread out on the right. Okay, and finally, by the way, ladies and gentlemen, this is your absolutely perfect normal curve. It's got a lot of good information. You might want to put a little star next to this one for number 8. It's got some good properties. And then over here, we've got something that's normally distributed, except this little one spot. It's got like a little extra bump. And so everyone take a moment and make sure you write this down exactly as I have it written. The left curve has approximately 68% of its data within 1 standard deviation from the mean, 95 within 2 standard deviations, and 99.75 within 3 standard deviations. The left curve is symmetric and standard. The right curve is not. So what I'd like you to do is take a moment and, based on what you've seen in these examples, make a list of what are the features of a normal distribution curve. Pause the video if you need more time. Okay, so the first thing I'm noticing is that a normal distribution is symmetric. A little bigger, there we go. A normal distribution curve is symmetric, and its mean, median, and mode are the same. The frequency curve of a normal distribution is symmetric. So the frequency curve, the histogram, they are all symmetric. Now this is new. The normal curve has points of inflection, meaning it changes concavity. One standard deviation above the mean and 1 standard deviation below the mean. A normal distribution only has 1 mode. It is not bimodal. And this is what we wrote down above. Okay, so at this point, if you need to rewind the video to get any notes on the graphs, take a moment and do that. Homework tonight is SLT 1 homework, pages 13 and 14. I will reveal the answers in a moment.